So what we're working on is sinusoidal modeling, and that's just fancy talk for we're going to be doing problems. We're going to be doing our word problems here. So we're going to be taking our situations, and we are going to be applying them to real-world situations. So we got the sine and cosine functions can be used to model a variety of real-world phenomenon that are periodic. Remember, periodic means that it follows a pattern regularly, and it follows the pattern, and then it repeats the pattern, and then it repeats the pattern, and then it repeats the pattern. That's our periodic. The key to constructing or interpreting a sinusoidal model is understanding the physical meanings of the coefficients we've explored in the last few lessons. So let's go through these again. Here are two equations that we're dealing with. Y equals a sine bx plus c, and then y equals a cosine bx plus c. Our a is our amplitude. So that's the distance that something rises and falls compared to your midline, that little middle part there. Our C value, that is your midline, also known as your average, that goes right through the middle, which is why we call it your average, because it's right there in the middle of everything. Our B value is our frequency, so that's how often you're going to get that curve during the normal period of 2 pi. And then the last thing, it's not actually part of your equation, but you still need to know your period. And that is how long does it take for one entire curve to happen. So let's take a look at an example here. We have the tides in a particular bay can be modeled with an equation in the form of A times cosine BT plus C. Tides are always going to be a periodic function, because if you think about it, you get high tide, you get low tide, and then it repeats. You get high tide, low tide, high tide, low tide. So it's always repeating that pattern. It's always a periodic. So we're told T represents the number of hours since high tide, and D represents the depth of water in the bay. The maximum depth of the water is 36 feet. Minimum depth is 22 feet. And high tide is hit every 12 hours. So part A, on the axis, sketch a graph of this scenario for 2 full periods. Label the points on this curve that represent high and low tide. So let's think about this first. This is a cosine graph. They tell me from high tide to high tide is 12 hours. So that is our period. Our period is going to equal a 12. Because high tide to high tide is 12 hours, that's our period. So they want us to sketch a graph for 2 full periods. So that means I got to go for 12 hours and then to 24 hours. That would be 2 full periods. What is our maximum depth? 36. So I'm going to estimate a 36 on here. So that's going to happen at 0. It'll have to happen at 12, because that's when it's going to return back to high tide, and it's going to happen at 24 hours. So then when would the first low tide happen? 6 hours. It would just be half of the 12. And our low tide is how high? 22 feet. When would our second low tide happen? After 18 hours. And again, that's going to be 22 feet. So then we can sketch our picture. It's going to go down and up, down and up. Creates like a little W there. They also told us to label the points on this curve that represent high tide and low tide. So I'm going to label my high tides as HT, so there's an HT there. There's another high tide here. And there's a third high tide there. And then same thing for our low tides. We got 2 of them. Low tide, low tide. So there's our sketch. That was actually pretty easy to come up with. Now what we have to do is they want us to determine the values of A, B, and C in the model, and then verify your answers and sketch are correct on your calculator. So let's take a look here. We have to find our C value, your midline, before you can find your amplitude. So again, that is your high plus your low divided by 2. Since it's the middle, that means it's just your average of your high and your low. So 36 plus 22 divided by 2. 29. So our C is a 29. So now we can find our amplitude. Our high minus our middle of 29, so 36 minus 29 gives us an amplitude of what? 7. So we got our A, we got our C. Last thing we need to find is our B. So that's using our formula. B times P equals 2 pi. What was our period again? 12. So we divide by that 12, our frequency, our B value, ends up being a pi over 6. So in order to check ourselves in the calculator, we're going to have to actually write out our equation. So D equals, and I'm just going to follow the equation that's up above in the problem. 7 is our A value, so 7 cosine. And then it's our B value with your T, so BT, so pi over 6T, plus your C value. So what I want you to do right now is take out your calculators, go to your Y equals. Go to our Y equals. Type in your equation, which I already have typed in from my earlier class today. 7 cosine pi over 6x plus 29. Yeah, and then when we do our zoom 7 for our trig, it's nothing there. It's because our numbers are different. So we've already figured out what our numbers are. We just have to put them into our window. So our x min should be 0. So then what was our x max? How far did we go on our graph? Nope, that's why. What was our x max going across? 24. And I'm just going to pick a number for my x scale. That's what is it going to go up by, so I'll pick a 4. It really doesn't matter what it goes up by. Okay, we can do 6 since that's what we did on our paper. We can go up by 6. So then our y min, 22. Our y max, 36. Do we want to go up by 1s? We can go up by 6. We can go up by 2s, whatever you want. Doesn't matter. That wouldn't work. So now when we look at our graph, does that match what we have drawn? Yeah. So that does now match what we have drawn on the paper. Let's take a look at our next part. All right, so letter C, we have a tanker boats cannot be in the bay when the depth of the water is less than or equal to 25 feet. Set up an inequality and solve it graphically to determine all points in time on the interval of 0 to 24 when the tankers cannot be in the bay. Round all times to the nearest tenth of an hour. Well, we already got that. We already have our equation for our curve. So we're going to use that. And the tankers cannot be in the bay if it's less than or equal to 25. So that's our inequality we would set up. Now, if we're looking at the graph, less than or equal, I'll show you in a second. So on the graph, that means here approximately is 25. So they can't be in the bay from this time to this time, or this time to that time. So we got 2 sets of times when they cannot be in there in a 24-hour period. So thankfully, there is this amazing invention called a calculator that's going to help us figure this out. We already have this typed into Y1. So in your Y2, we're going to put in 25. Just the number 25.
Oh my God.
So what you need to do is get your little blinker guy.
Oh, and then we go from the beginning to the end. The little blinky fellas.
So get your little blinky guy to get to an intersection.
Blinky boy. What I call him. Blinker McClinker. We've got 4 hours to...
Mine doesn't move too.
8 hours.
No. We got to go to the nearest tenth of an hour.
4 hours.
Oh my gosh, that's taking forever.
I have to get 4.1 hours to 7.9.
No.
I have like 7.65. Oh wait, hold on, no.
So I get my little blinky guy over there.
7.3.
Oh, too far. There we go. Now I'm right on the intersection there.
I did not get 4. I got 4.
So if I look at my x's, it's 4.18. So to the nearest tenth, it would be 4.1.
4.2.
4.2. So 4.2 is less than or equal to t. So now we got to figure out the other value over here. So move your little blinker guy over. I did not get 7.9. No, it should not be 20. Nope. Nope. Oop, too far.
I got 7.91489.
Let's see here. There we go. 7.9.
Close.
So that represents, again, that first time when the tankers can't be in the bay. Now this is a periodic function and it repeats how many hours? No. Every 12. So that means the other time you just add 12 to them. To 19.9. So they can't be in there from 4.2 to 7.9 or 16.2 to 19.9. Yes, that's in military time. So these examples on the back, you don't have to sketch graphs for them. Sometimes you do, like we did on the last one. Sometimes you don't. So here, example 2, the height of a yo-yo above the ground can be well modeled using the equation given here, where h represents the height of the yo-yo in feet above the ground and t represents time in seconds since the yo-yo was first dropped from its maximum height. So they want us to determine the max and the min heights of the yo-yo and show your calculations that lead to your answers. So if we're looking for the max and the min, what are we really looking for of the graph? Begins with an R. You're really looking for the range. We've practiced finding our range already. That's your C plus your A and your C minus your A. That gives you your range for this. So C is 2.25. A is 1.75. So, yeah, 1.75. What's our max height? 4 feet. That's our max. So now 2.25 minus 1.75 gives us a min of 0.5 feet. There you go. Max, min, found our range. Then they want to know how much time does it take for the yo-yo to return to the maximum height for the first time. So it starts at the maximum height, goes down, comes back up. It means we're really looking for the what? The period. You're looking for how long it takes to return back to starting. So B times P equals 2 pi. Looking at our equation, what's the value of B? Pi. That's right there. That's your B value. 2 what though? What's our units? Seconds. Yep, because it says time in seconds right there. So it's going to take 2 seconds for it to go down and come back up. So exercise number 3, we got a Ferris wheel is constructed such that a person gets on the wheel at its lowest point, which is 5 feet above the ground, reaches its highest point of 130 feet above the ground. The amount of time it takes to complete one full rotation is 8 minutes. That means it goes from the low up to the top, back down to your low. That takes 8 minutes. A person's vertical position, y, can be modeled as a function of time in minutes since they boarded by the equation given here. Sketch a graph of a person's vertical position for one cycle and then determine the values of A, B, and C. Show the work needed to find your answers. Okay, so they start by boarding on the Ferris wheel when it's at its lowest. What is its lowest height? 5 feet. So we start right here at 5 feet. And we end also at 5 feet. Because we go up and around. It reaches its maximum height of what? 130. That's going to be in the middle between my 2 5 feet there. So you're going to kind of estimate where the middle is. And it takes how long for it to get back to 5 feet? So that means this happens at 8 minutes. When is my maximum going to happen? At 4 minutes. And then we draw our curve. Nope. So we have to determine the values of A, B, and C. So again, you have to get C in order to find your A. So high plus your low divided by 2. It's going to be a decimal. 67.5. That's our C value. A, do your high minus what we just got for our C value. $62.5. So there we go. We got 2 of them. C is 67.5. A is 62.5. We got 1 left, which is our B. So B times P equals 2 pi. How long is our period? 8 minutes. So I'm going to put 8 in for the letter P. Divide by 8. B is pi over 4. And there we go. We got our last one.
That made that sound like this was going to be absolutely terrible. Wasn't that bad? I'm always prepared for the worst.
All right, example 4, last one in our notes for today. We got the possible hours of daylight in a given day as a function of the day of the year. In Poughkeepsie, New York, the minimum hours of daylight is equal to 9 hours. And the maximum hours of daylight is equal to 15 hours. If the hours of daylight can be modeled using a sinusoidal equation, what is the equation's amplitude? So that means we're looking for letter A, but what do we need to know before we can find A? C. Got to find C first. High plus low divided by 2. So 15 plus 9 or 9 plus 15, doesn't matter.
It's going to be 10.5.
False. It's going to be 12.
Oh, I did 6 plus 15.
So then your high minus what we just got for our C value gives you your amplitude, which is 3.